Hi, I am Josh Patrick G. Samson of PSECE 41. I am here to discuss to you what is error detection. First, let us know what is error detection. It is the process of monitoring data transmission and determining when errors have occurred. Error detection techniques neither correct errors nor identify which bits are in error. They indicate only when an error has occurred. The purpose of error detection is not to prevent errors from occurring, but to prevent undetected errors from occurring. The most common error detection techniques are redundancy checking, which involves vertical redundancy checking, checksum, longitudinal redundancy checking, and cyclic redundancy checking. First, let us all discuss what is redundancy checking. Duplicating each data unit for the purpose of detecting error is a form of error detection called redundancy. Redundancy is an effective but rather costly means of detecting errors, especially with long messages. It is much more efficient to add bits to data units that check for transmission errors. Adding bits for the sole purpose of detecting errors is called redundancy checking. There are four basic types of redundancy checks, namely vertical redundancy checking, checksum, longitudinal redundancy checking, and cyclic redundancy checking. Let's discuss what is vertical redundancy checking. Vertical redundancy checking, or simply called as VRC, is probably the simplest error detection scheme and is generally referred to as character parity or simply parity. With character parity, each character has its own error detection bit called the parity bit. Since the parity bit is not actually part of the character, it is considered a redundant bit. Next is checksum. Checksum is another relatively simple form of redundancy error checking where each character has a numerical value assigned to it. The characters within a message are combined together to produce an error checking character or checksum, which can be as simple as the arithmetic sum of the numerical values of all the characters in the message. The checksum is appended to the end of the message. The receiver replicates the combining operation and determines its own checksum, while the receiver's checksum is compared to the checksum appended to the message, and if they are the same, it is assumed that no transmission errors have occurred. Next is longitudinal redundancy checking. Longitudinal redundancy checking, or simply called as LRC, is a redundancy error detection scheme that uses parity to determine if a transmission error has occurred within a message and is therefore sometimes called message parity. With LRC, each bit position has a parity bit. The LRC bits are computed in the transmitter while the data are being sent and then appended to the end of the message as a redundant character. In the receiver, the LRC is recomputed from the data and is recomputed to the LRC is compared to the LRC appended to the message. If the two LRC characters are the same, most likely no transmission errors have occurred. If they are different, one or more transmission errors have occurred. And lastly, the cyclic redundancy checking. Cyclic redundancy checking is probably the most reliable redundancy checking technique for error detection and is a convolutional coding scheme. With CRC, approximately 99.999% of all transmission errors are detected. In the United States, the common CRC code is CRC-16. With CRC-16, 16 bits are used for the block check sequence. With CRC, the entire data stream is treated as long, continuous binary number because the BCS is separate.
created using Powtoon.